All right, so hello everybody, and thank you for being here. We are 2021's community water team, so we were one team within AMRE for the summer of 2021. So for those of you who don't know, AMRE is an acronym for Applied Methods and Research Experience, which is an annual summer applied research program here at the College of Worcester. We are not your typical AMRE team. Most teams consist of 2 to 3 upperclassmen who spend the whole summer working as consultants for a single company trying to solve a specific problem. But our team has 6 members, 5 of whom are rising sophomores, and our focus is far more broad than that of most AMRE groups. We used various techniques to evaluate and propose solutions to issues related to stormwater runoff in the Worcester community. So next up, Elizabeth is going to explain stormwater runoff.
Thanks, Luke. Stormwater runoff is built up precipitation that runs across ground surfaces and is eventually deposited back into a body of water or soaks into the ground. As precipitation increases due to climate change, there is an increase in stormwater runoff, creating issues around flooding, especially in areas with lower elevations. Non-point source solution is caused when precipitation moves across the ground, picks up pollutants, and moves them into water sources. Our team collected data from 4 different locations: Secrest Arboretum, Apple Creek, Knights Hollow, and the golf course here on campus. We used several different methods of data collection, including tree coring, flow measurements, measuring mud depths, and researching infiltration rates of the soils to see how well stormwater runoff drains and is absorbed in Worcester. And next up, we have Shamari to talk about the focus of our project.
Thank you, Elizabeth. Our project is focused on helping our community reduce the harmful causes and effects of stormwater runoff while acknowledging how our community has been affected. We work with a variety of clients and stakeholders such as Davy Tree, Secrets Arboretum, Trout Unlimited, Environmental Design Group, also known as EDG, local government, residents, and etc. Davy Tree conducts tree services such as inspection, removal, and trimming. Trout Unlimited focuses on fish conservation and macroinvertebrates, and EDG focuses on civil engineering and ways to conserve our environment. To help our clients, we offer surveys for environments, we analyze data that we gather, draw conclusions from results, and present them in a medium that leaves an impact, such as a NIPSIS report. And next we have Grace to talk about our tree, climate, hydrology, and soils observations.
Thanks, Shamari. So during our experience, the water team learned and practiced a wide variety of skills in our field. So while many overlap, they can be roughly divided into 3 categories regarding soil, trees, and water sampling and just analysis. So for our trees, we examined how they interacted with the environment, how they took up water and nutrients from year to year, and what that could tell us overall about our changing climate. We learned how to core trees, and examples to the far right of the screen, to analyze the tree rings, and to visualize the changes over time. For the soil analyses, we examined the compositions and presence of soil at our different field sites, so evaluating factors such as chemistry, permeability, and depths of the soils can provide insight to the daily trends, as well as what happens during those increased stormwater events. For our water analyses, we examined both the physical and chemical interactions. So we looked at how it interacted with stream beds, different floodplains, and catchment basins, as well as observing how it interacts with the biogeochemical cycles within our watershed and in the more general sense of like Ohio, Northeast United States, that kind of stuff. So taking all of those methods, we looked at different flow rates and different chemical testing, and we got a better understanding of what pollutants and nutrients might be picking up, putting down, and just what's happening in our waterways. So we take all of this different information, this data, and now we're going to put it towards different analyses and eventually report. So I'm going to hand it over to Ellen for a little bit more information about that.
Thank you, Grace. During the course of 8 weeks of AMRE, we have drafted up about 40 figures based on the data we have collected. We created maps, graphs, and tables utilizing several softwares. As shown on the top left, we have used ArcGIS to locate the sites we worked on by placing pins and overlaying the sites with defining colors. We utilized Studio R and Igor to create graphs and to run statistical tests. An EXO was used to record and organize the data we have collected. On the lower left side, this is a picture of a tree ring, and we have used software such as Cofetcha and RSAN to assess the quality of cross-dating and for the accuracy when measuring the tree ring series. Also, we have used other softwares like Teams and have had several in-person meetings as a team and with other clients to communicate with each other. Now Luke will be talking to us in depth about the reports we have drafted.
Yeah, thank you, Ellen. So all of our findings were written into technical reports that were then submitted to the appropriate clients. So for example, the leftmost report here examines bald cypress trees at a local arboretum and their potential to help mitigate the impacts of increasing precipitation. So this report was sent to the director of the arboretum and a professor at Cleveland State University who studies that sort of thing. These reports included several notable findings. First of all, as the climate changes, Worcester is getting more and more precipitation, so stormwater management is becoming ever more important. By measuring tree rings, we also found that bald cypress trees flourish in rainier years, right? So this makes them a favorable species to plant for the long term. Also, by examining the land cover around two different retention basins, we found that basins surrounded by impervious surfaces, so think roads, buildings, concrete, that sort of thing, they respond far more abruptly and dramatically to precipitation events than retention basins surrounded by more natural surfaces. Right? And so we spent several weeks of this project making these reports, and we produced over 50 pages of finished report in all. And so next up, Kai is going to explain the next major phase of our project.
Thanks, Luke. Last week, our team began working on a lengthy report called the Non-Element Non-Point Source Implementation Strategy, or NPSIS, NIPSIS for short, whose guidelines are established by the Ohio EPA to provide to one of our clients, Environmental Design Group. Our report is based on the Apple Creek Huck 12 watershed area, which Huck is just a size for measurement. The larger the number, like 12, the smaller the area. For reference, Apple Creek Huck 12 area is about 39 square miles. The report highlights a wide range of characteristics, features, and properties, such as local soil types, land usage, history of the area, and more. It also includes details from our larger related watershed areas, up to the Huck 8. Due to the significant length of the report, we will unfortunately not be able to finish it in its entirety with the time given to us. However, we have made excellent progress on the report and have passed along a copy to the Environmental Design Group for review and feedback, which we plan to implement and pass along to our successors, who will continue working on the NIPSIS report. Now, I'd like to give the floor back, which in the next slide, everyone will briefly mention a quick statement on one of the skills they have learned and how it might apply to them in the future.
Yes, Emory has prepared me for the future by helping me improve my communication, professional, and teamwork skills, which is very important for my image in the workforce. I've also learned new terms and techniques that are used in the geology department, but could also be used in my future career.
I have learned different geologic techniques and how to analyze that data, which I didn't know before due to classes being online. So those will be applicable to my environmental geoscience major.
I believe the network I have built through this experience would be the biggest thing I'll be taking away.
Not only did I gain technical and analytical skills for the field of earth sciences, but I developed my professional skills as well. From resume building to in-person interactions in both the field and office settings, I learned more on how to present myself for the professional scientific world.
I improved my time management skill, which is critical to meeting the copious amounts of deadlines that just keep seeming to be popping up. And this could easily translate nicely towards any job I may hold in the future.
And I learned how to use lots of new software like ArcGIS, Adobe Illustrator, and even Microsoft Teams in a collaborative way, as well as gaining valuable experience working in a group. So that's all we have for you. I hope you enjoyed, and thank you for watching.